Good morning, everyone. I hope my voice is audible. Good morning, good morning. Okay, so less students, 23 students only. Okay, please be with your copy and pen with you. So I'm sharing my screen. Okay, you will tell me if you can see or not. So last class, are we doing about the design concepts of plain sedimentation tank? If I'm not wrong, we were in the middle of your design concepts. Yes or no? Can somebody tell me? Am I correct? Are we were we doing this design concepts in plain sedimentation tanks? Yes or no? Nobody remembered. My voice is not clear. Is it clear now? Is my voice clear now? Okay, so what happened? Let me see. Is it clear now? Yes. Okay. Others, can you hear me now? Okay, fine. Fine. I don't know what happens. Sometimes it happens with this technical problem. Okay, it happens. Okay, again I'm sharing my screen. So as far I remember, we were doing this design concepts in plain sedimentation tank, right? So in your last class, we have done up to like we were talking about the overflow rate and the settling velocity. Yes, overflow velocity and settling velocity, and what was the condition so that 100% removal of particles is can be expected. The condition was your Vs your Vs should be greater than or equal to your overflow velocity. Okay, so you can, if this condition arises, then you can expect 100% removal of your of the particles from the below the sedimentation or settling tank. Okay, but if it is vice versa, that if Vs it is less than your overflow velocity, then you cannot expect any removal of particles from the settling tank. Okay, so next you write down. Actually, you need to write down these points. Okay, this one you write down: overflow rate. Okay, overflow rate formula you write down. This is V naught is equal to discharge by surface area. Discharge is again equal to volume by time. Okay, then volume is again equal to surface area into depth. Okay, so finally we get the formula as depth by time. So you please quickly write down this formula. The formula for overflow rate. Overflow rate V naught. Small V naught is equal to, you write down. Written. Okay. So let's proceed to the next formula. Write down this formula. This one. This is the formula for your flow velocity. Okay. Flow velocity formula you write down. Small v is equal to Q by BH, where B is the width of the tank and H is the depth of the water in the tank. Written. Okay, next you write down. You write down this blackish line. Okay, from here. Normally, adopted values of overflow rates vary between 12 to 18 meter cube per day per meter square of planned area for plain sedimentation tanks, and between 24 to 30 meter cube per day per meter square of planned area for sedimentation tanks using coagulants as aids. Okay, you write down this line. You can write down in short form also. So like for plain sedimentation tank, you can give a dash and write down the overflow rates vary between 12 to 18 per meter cube per day per meter square of planned area. Okay, and for your sedimentation tanks using coagulants as aids. You write down the overflow rate is between 24 to 30 meter cube per day per meter square of land area. Okay, write down this line. After writing that one, you proceed to write from here the values of depth. Okay, the usual values of depth ranges between, that is the water tank depth. Okay, 3 to 4.5 meter with 1.8 meter as minimum and 6 meter as maximum. Okay, this is the water tank depth. So you write down the depth because sometimes in numerical problems your the depth of the water tank it might not be given in the question. So you for solving out some like surface area or something like that, so you need to know the value. Okay, what's the value for your tank ranges between. So if it's 3 to 4.5, it's your choice whether you take it to be 4 or you take it to be 4.2. Okay, so it depends upon you. And actually in addition to your this water tank depth, there is you need to add something while you find out the total depth of your water tank. Okay, that is when suppose you are taking the water tank depth to be 3, suppose 4 you are taking. Okay, then also you need to add one value, and that value is known as your freeboard. Okay, freeboard. So freeboard is what? Free board. Okay, BOARD. This freeboard, this is like it is this space. This is a spacing. Okay, this is a spacing between your the slab of your water tank and the surface of your water. Okay, water in the tank. Okay, the spacing between the water in your tank and the slab. Okay, the slab that is used to cover your tank, there is a slight spacing. Okay, so that spacing is for your some safety purposes, like suppose while the people they enter a tank to clean the tank. Okay, some if some emergency or some accidents happen, so they can just they can put out their head and they can breathe. Okay, and also so that the water inside the tank it does not touch the slab of your tank, because the slab it might be dirty. So if the slab and the water it keeps on touching, so the water will obviously it will also get what dirty, isn't it? So there is a slight spacing. There is a spacing between the surface of the water and the below the slab. Okay, so that is known as your freeboard, and that freeboard you need to add while calculating the depth of the tank. Okay, you will see while we will calculate the numerical, you will see there they have added. Okay, so you have written up to here. So next you write down this formula. This is the formula for detention time, as we already have learned about detention period. So detention time for formula for a rectangular tank. I have shown you the image of a rectangular tank and that of a circular tank also. So you write down the formula up to here. And if that is finished, you write down this line. The detention time usually ranges between 4 to 8 hours for plain sedimentation and from 2 to 4 hours when coagulants are used. Okay, you write down up to here to here. Also, the width is also given here. The width of the tank is normally kept equal to 10 meter and not allowed to exceed 12 meter or so. So the width is taken to be equal to 10 meter, okay, and it is not allowed to exceed 12 meter. So between 10 to 12 it is kept. The length of the tank it is not generally allowed to exceed 4 times the width. So the length it is not allowed to exceed 4 times the width. Okay. The length of the tank is generally not allowed to exceed 4 times the width, though it may vary from 1 to 6 times its width, and it may vary from 1 to 6 times of the width. Okay, that means the length of the tank it can be 1b, it can be 2b, 3b, 4b, okay, 5b, like that up to 6b. That means 6, if the width is given to you, you can multiply directly with the width, okay. But it depends upon you whether you take it to be 4b, 5b, 6b. If you somebody is taking 5b and somebody is taking 4b, obviously the answer it will differ, okay. But that differ will not make your answer incorrect, okay. So it depends upon the variation, what variation you are taking.
Ma'am, explain again, ma'am.
Which one? The length?
Yeah, the one that you just explained, right?
This length, right?
Yes, ma'am.
Okay. So you have written this formula, okay. This, let me wait. Okay, so you see here the detention period, it is you write down, okay, directly you have to remember that for plain sedimentation, okay, this one will be mentioned in your question, that whether it is a plain sedimentation tank you are designing, or you are designing a tank where plain sedimentation aided with coagulation, okay. And coagulation part we have not yet studied, now we will study in the next step, okay. The next treatment is about your coagulation. So your you write down this line, then with you can write like this, okay. Width is between your 10 to 12, okay. The width of the tank, if it is not mentioned in your question, then you can assume the width of the tank to be between 10 to 12 meter. It can be 10, it can be 11, it can be 12. Okay, then the length of the tank, it is not allowed to exceed, or it cannot be greater than 4 times of the width. Suppose the width you are taking to be 11 meter, okay. The width you are taking to be 11 meter, that means if you're now have to find the length, so the length it cannot be greater than 4 into 11, okay. That will be 44. So the length of the tank it is not allowed to be greater than 44 meter, okay. But the length it can vary between, okay, it can vary between your 1 to 6b. That is, it can be length it can be like, suppose it can vary between 1 to 6b, means it can be 1b, okay. It can be 2b, twice the breadth. It can be thrice b, okay, or it can be 4b. But again it's written here that it cannot exceed 4b, so we can take the length value up to 4b, okay. since it is already mentioned that we cannot, the length cannot exceed between like greater than 4b, so we will assume this length to be, it might be 1b, 2b, 3b, 4b. If one student is taking, suppose the length to be 1b, and someone is taking length to be 3b, then the answer it will obviously vary, but the process it is not wrong. Okay, in design nobody can give marks according to your answer, because since it is a design problem, so your answer and your classmates answer it may vary. Okay, we don't give marks according to your answers, we see the process. If the process is correct, then you obviously everyone will get marks. Okay, so this is your all about your design of your plain sedimentation tank. And one more line is there, you see here. Okay, the cross-sectional area of the sedimentation tank is such as to provide a horizontal flow velocity. Okay, so the horizontal flow velocity, it ranges between 0.515 to 0.9 meter per minute, normally kept at 0.3 meter per minute. Okay, so you can write the formula for horizontal flow velocity ranges between 0.15 to 0.9 meter per minute, and normally it is kept at about 0.3 meter per minute. Write down this line. Okay. Now quickly we will jump to one numerical problem.
Ma'am, wait.
You're writing. Okay. Okay.
Yeah. Ma'am, or will you rather share this PDF?
Which one?
This all of this PDF as a PDF,
Oh
and
yeah,
can share
yeah,
it.
yes. This one, I guess I have circulated that day. I have given this one.
Oh,
Sedimentation,
okay, ma'am.
I have given initially, but the others from your intakes I have circulated. Okay, in your CR group I have given. Actually, this is a PDF, not a PDF. Actually, I have made that. It is a, this photocopy of your book. I have taken a photo, then I have converted to PDF. Okay, so it's better if you can buy the book, then it will be easy for you. The rather than seeing from your laptop or mobile, I think it will be better if you buy the book. Okay,
Yes, ma'am. Ma'am, can you suggest us the book name?
book name, yeah, book. Actually, there are many books. Okay,
Mm.
but then also you can buy the one that I am using is a two-part book. Okay, there is volume one and volume two. Okay, your chapter one is basically about your volume one, that is your water supply engineering. Okay, water supply engineering by water supply engineering by SK Garg. SK Garg. Okay, this is a volume one. This is a volume one. In this book, in this part of your book, you will find chapter water supply engineering. Okay, raw water supply engineering. The sewage part you will not find. Okay, and for your again the volume 2 is also there. You can ask in the shop that volume 2 of SK Garg is about your sewage. Okay, you can buy both the books, and these books are quite effective for your later your this exams and all. No, this competitive exams and all. This book is quite effective. You can buy. And another book is also there about BC Punnia. Also, you can buy. Okay, the author name is BC Punnia. That one also you can buy. Sorry, it went. SK Garg and BC Punnia. Okay. You can buy this one also, and the one I am using is your SK Garg. SK Garg Water Supply Engineering Volume 1, and Volume 2 is about your sewage disposal and not water pollution, I guess air pollution engineering. Okay, sewage disposal and air pollution engineering, SKGAR. That will be all about your chapter 2 and chapter 3 also. Pollution chapter is also there. Okay. I hope you have completed writing. Please be quick so that I can proceed to the numerical. Finish, right?
Yes, ma'am.
Okay, so let us jump to the numerical. So you see this numerical. The question is the maximum daily demand. Okay, maximum daily demand we have already learned. The maximum daily demand at a water purification plant has been estimated as 12 million liters per day. Okay, so design the dimensions of a suitable sedimentation tank for the raw supplies, assuming a detention period of 6 hours and the velocity of flow as 20 centimeter per minute. Okay, so the quantity of water it is given as 12 million liters. Okay, the maximum daily demand, or you can say the quantity of water. Okay, obviously it is in liters, so it will be the quantity capacity. Okay, sorry, the quantity of water to be treated in 24 hours. Okay, so it is given as your 12 into 10 to the power 6, since it's written as million. Okay, million liters per day, so they have written it to be 10 to the power 6 liters. Okay, so now since it is a day, okay, here day is mentioned. Okay, but we need to convert it to hours. Okay, because detention period it is mentioned in hours. Okay, so how we will, first we need to find the capacity of the tank. Okay, what will be the capacity of the tank, we will need to find out first. Then for finding the capacity, we need to multiply the quantity of water with your detention period. Okay, if we multiply your capacity multiplied by your detention period, then we will get the capacity of your tank. Okay, so here it is 12 into 10 to the power 6 divided by 24. Since it is million liters per day, so we have converted it to hours. So it is divided by 24 into your detention period. We get 3 into 10 to the power 6 liters. Okay, then again if we convert these liters to cubic meter, then you will get 3000 cubic meter. Okay, you will get to be 3000 cubic meter. So the capacity of the tank, you got it to be 3000 cubic meter. given to you? Flow velocity is given. Okay, flow velocity, it is given to be 20 centimeter per minute. Okay, but since we are converting the capacity to meter, okay, since we are converting it to meter, so we need to convert the flow velocity also to meter. So since it is 20 centimeter per minute, if we convert it to meter, it will be 0.2 meter per minute. Okay, now you see your, it is given to you to find out the dimensions. What is dimensions? Length into breadth into your height, that is your depth. Okay, so you need to find the length, width and the depth of the water tank. We have got the capacity and now we need the dimensions. So to find out the length of the tank, what is the formula? Okay, to find out the length of the tank, you see, velocity of flow into detention period. You try to remember this formula. Okay, your length of the tank is your velocity into your detention period. Okay, so velocity, it is 0.2. Okay, and detention period, we since your velocity, it is in your meter per minute. Okay, so 6 hours detention period, it is given as 6 hours. Okay, and we need to convert that hours to minutes. Okay, because we need to cancel your length, you know the length unit is meter. Okay, so in order to since your minute, meter per minute, okay, your velocity unit is meter per minute. If you multiply it by minute, then okay, these two will get cancelled and you will get in meter. So you now like that you need to actually see the things. Okay, so now that's why we need to convert the 6 hours to minutes, and that is 6 multiplied by 60. Okay, then we get it to be 72 meter. Okay, we got it to be 72 meter, the length we got. Okay, so after getting the length, now we need to find out the your depth. Okay, we need to find the depth also, and we need to find the width also. For finding the width of the tank, what you need the cross sectional area. Okay, first you need to find the cross sectional area. So what is the cross sectional area formula? It is your capacity of the tank by length of the tank. Okay, since your capacity, it is in meter cube, yes, and your length is in meter, so if you cancel both, you will get the area unit is what? Meter square. Okay, so that's why we are dividing the capacity by length. If you divide both, you will get it to be 41.7 meter square. Okay, so now you got the cross sectional area. Now as soon as you find the cross sectional area, now you can find the width of your tank. So how you find the width of your tank? We can see your depth is not given. Okay, depth is not given, but you can assume the depth, because we have already learned the depth, it might vary from your it is given something like 3 to 4.5, right? So they are taking the depth of the tank, they are assuming. Okay, they are assuming the depth of the tank to be 4 meter. Okay, 4 meter they are assuming, and now they are finding the width of the tank by dividing the cross sectional area and the depth. Okay, so cross sectional area is in meter square and depth is in meter. So if you cancel both, you will get in meter, so that will be your required width. Okay, so width, they got it to be 10.5 meter. Now width, now the depth, water depth, they have already assumed it to be 4 meter, but as I already said that you need to add a freeboard. Okay, you need to add a freeboard for your safety purpose. So the overall depth, okay, so the overall depth, it is your 0.5 meter, 0.5 meter to 1 meter. Okay, the freeboard depth, it varies from, you can say, 0.5 to 1 meter. It's not a very big depth. Okay, it's 0.5 to 1 meter is taken. So here they are taking it to be 0.5, and they are adding with the water, the depth which they have assumed, that is your 4 meter. Okay, so the total, they have got it to be 4.5 meter. Okay, so now they have got a rectangular sedimentation tank whose sizes are, they have got it to be 72 meter is the length. Okay, 10.5 is the width, and 4.5 is the required depth of the tank. Okay, so you can for now you can take a screenshot, or if you're writing, then you can write. Okay, later you note it down in your copy. Okay, acha. And this question is your assignment. This question is your assignment. The now for the now the time being, you please take a screenshot. Okay, this question is your assignment. The notes I will share it by today. Okay, you see how they have done. Okay, and then you again note it down in your copy as your assignment. Okay, this question 9.3, example 9.3. First you try to do without looking the answer. Okay, after that you try, if you are not being able to do that, after that you try to see the answer and then you do. Okay, but first you should try a numerical without seeing the solution. Okay, so your first class is, it is about to end. Okay, so next class, next is your 10:15, right? So we will meet at 10:15 and we will start our next topic. Okay, we will start our next topic, that is about your sedimentation aided with coagulation. Okay, so now you take a 10 minutes break. 10 minutes mean we will meet at 10:15. Okay, we will meet at 10:15. I will provide you a new link. Okay, through that link you join. Okay, so take a 10 minutes break.